So in this example, let's multiply and simplify the square root of 5a to the 7th times, so you don't see the symbol here, so it's times, square root of 15a to the 4th. So we know how to multiply radicals, right? We can combine into one big radical as long as the indices are the same. What are the indices here? Or what is the index here on both? It's 2. When you don't see it, they're square roots, right? So one big square root, and then you multiply the radicands. So 5a to the 7th is the first radicand times 15a to the 4th is the second radicand. But be smart about this. Don't just multiply 5 times 15 because you're going to have to simplify it anyway, and you'll be spinning your wheels a little bit if you do that. So look for repeated factors in 5 and 15. Do you have any common factors, repeated factors between 5 and 15? 5 repeats itself, right? In fact, so you guys probably know that 5 times 15 I think is what, 75? So what I'm saying is don't do that because you're going to have to factor that 75 anyway, aren't you? So the idea is if you know that you have to take 5 times 15 and then that's going to be part of the radicand, that's going to be a factor in the radicand, and you have to simplify it anyway, why not just think of the 15 as 5 times 3? So that essentially you have a 5 squared times 3 or 3 times 5 squared is probably how I'll write it underneath the radical. So think ahead because you know you're going to have to simplify it anyway. So I'm going to take out that 5 squared. I'll actually put the 5 squared on the left, and then I'll put the 3 on the right. Okay, and then we've got, what else? We've got like bases, right? a to the 7th times a to the 4th makes what? a to the 11th, but we're going to have to simplify that underneath the square root anyway, aren't we? So how are we going to want to rewrite it? We're going to want to break up that a to the 11th into a perfect square factor and the leftover non-perfect square factor. What's the next perfect square down from a to the 11th? a to the 10th, what's left over? A. So instead of really, in the first place, instead of multiplying and getting a to the 11th, why not just take the a to the 7th and the a to the 4th and realize, oh, three of these factors of a in the a to the 4th will multiply times the a to the 7th to make the a to the 10th. And then that leaves me with one factor of a left over. I don't really care how you think of it as long as you break it up like that eventually, right? Now, can you check your work here? If you were to actually multiply out that radicand, you should get what you would have got originally if you had just not even thought about it and multiplied 5a to the 7th times 15a to the 4th, right? So you should get 75. Oh yeah, 5 squared times 3 is 75. a to the 11th. So you can check it by multiplying everything if you want. Okay, so now what can you pull out? So what the square root breaks up over multiplication. So what's the square root of 5 squared? 5, so you can pull out a factor of 5 out front. What's the square root of a to the 10th? a to the 5th, so you can pull out a factor of a to the 5th out front. And then just clean it up. So the final answer, 5a to the 5th out front, that's multiplication all the way, right? 5a to the 5th times what's left? Times, well, square root of 3a, yeah. Does that make sense? Okay, so that's putting both ideas together, multiplying radicals and simplifying radicals.